A normal Tuesday morning. Someone is pouring coffee. A school bus stops on a wet street. A girl in Tokyo opens her laptop. And right now, while you watch this, the sun is gone. Not dimmed, not collapsed, just gone. We will not know for another 8 minutes and 20 seconds. That is how long sunlight takes to reach us. I thought a long time about which moment to start this story with. Then I realized any moment works. You are already inside it. Here is the part most people miss. The sun does not just send light, it sends gravity. And gravity travels at exactly the same speed, the speed of light. This is general relativity. Einstein, 1916. Confirmed 100 years later by gravitational wave detectors when they caught the signal from two black holes merging more than 1 billion light-years away. So for 8 minutes and 20 seconds after the sun vanishes, the Earth has no idea anything is wrong. We keep orbiting in a perfect curve, as if the star at the center is still there. Photons that left the surface 8 minutes ago keep arriving on schedule. Plants keep doing photosynthesis. Solar panels keep generating power. The cat on your windowsill keeps sleeping in a warm patch of light from a star that no longer exists. This is the last normal breakfast of the human species, and nobody knows it. Then those 8 minutes end, and two things happen in the same instant. The sun goes black in the sky, not like sunset, no orange band on the horizon, just total darkness with stars suddenly visible at noon. And at the exact same moment, the Earth lets go. Gravity is gone. Our planet stops curving. It flies off in a straight line at 30 kilometers per second, about 107,000 kilometers per hour. Tokyo, Lagos, Buenos Aires, Reykjavik, all moving together in the same direction into the dark. The moon comes with us. Its orbit was always around the Earth, not the sun. So it stays. But it goes dark too. The moon only shines because it reflects sunlight, and there is nothing left to reflect. A black disk against a black sky. Within an hour, every observatory on the planet sees the same impossible thing and reports the same impossible word. By then, it is already too late to plan anything. The first week is strange, stranger than the disaster movies make it look. Electricity still works. Power plants do not care about the sun. Coal, gas, nuclear, hydro, all running. The internet is up. Phones charge. People drive to grocery stores in headlights at noon. There is no orange wall of fire, no screaming wind, just dark and cold. Slowly, steadily cold. According to David Stevenson, professor of planetary science at Caltech, the global average surface temperature drops below 0 Fahrenheit within 7 days. Within a year, -100. Within a decade, -200. By that point, your breath is not just a cloud in the air. It freezes as you exhale and falls. Crops die first. Photosynthesis stopped on day 1. The phytoplankton in the oceans, which produce roughly half the oxygen we breathe, start collapsing within weeks. The food chain breaks from the bottom. Herbivores starve. Predators starve next, and the great dying begins quietly, in slow motion, while the lights are still on. Now the cold gets weird. After a year, water vapor falls as snow that does not melt. After 10 years, carbon dioxide freezes out of the atmosphere and drifts down as dry ice. After a few hundred years, the air itself begins to give up. Nitrogen condenses at -196 degrees Celsius. Oxygen at -183. They fall, actually fall as liquid, then as snow, onto the dark, frozen continents. Stevenson estimates a final equilibrium temperature for Earth, balancing the trickle of heat leaking out from the planet's core against the heat radiating into space. The answer is around 43 Kelvin, -380 Fahrenheit, -230 Celsius. The oceans freeze from the surface down. But here is the irony. That ice insulates everything underneath. The deep ocean, the actual liquid bulk, stays liquid for hundreds of thousands of years. The Earth's core keeps radiating heat upward. Hydrothermal vents on the seafloor keep pumping mineral water at 300 degrees Celsius into the dark. And life does not really care about the sun. Some of the oldest life on Earth has never depended on sunlight. Extremophiles, bacteria and archaea living around deep-sea hydrothermal vents. They eat sulfur, they eat methane. They run their whole metabolism on chemistry, not photons. They have been doing this for at least 3.5 billion years. For them, the death of the sun is almost nothing. A surface event. Some climate news on a planet they have never seen. The American Space Agency, NASA, spends serious money looking for life exactly like this. Not on Mars, not on planets like Earth. On moons like Europa around Jupiter and Enceladus around Saturn. Moons with a frozen crust and a hidden ocean underneath, kept warm by tidal flexing and internal heat. The Europa Clipper probe launched in October 2024 to study one of them up close. And here is what gets me. After a few centuries without the sun, Earth becomes Europa. Same architecture, frozen crust on top, hidden liquid water below, warm chemical engine at the bottom. The exact kind of place we send probes to look for alien life. For 1 billion years, Earth might still have something alive inside it. Not humans, not anything that ever looks at the sky, but something. Meanwhile, the planet itself just keeps going. Without a star to anchor it, Earth becomes what astronomers call a rogue planet, a nomad world drifting through interstellar space. And here is the part that took me a long time to accept. Rogue planets are not rare. They are probably the most common type of planet in the Milky Way. In 2013, a Sky Survey telescope in Hawaii spotted one. 6 times the mass of Jupiter, about 80 light-years away, drifting through the constellation Capricornus. 12 million years old, still glowing faintly in infrared from the heat of its own birth. No star, just out there, alone. Another one was found by European telescopes a year earlier, about 100 light-years away. Same story, no host. Some estimates suggest there are more of these in our galaxy than stars. An entire population of dark worlds that nobody can see, that nobody talks about, that nobody named. If this is the kind of question that pulls you in, subscribe, drop a comment. Tell me which corner of the solar system you want me to take apart next. Earth, if this happened, would join that crowd. A black sphere with frozen nitrogen for soil. A subsurface ocean nobody can reach. A dead moon following it like a memory. And in 1 billion years, if any sensor anywhere ever found it, that would be the report. Cold body, trace internal heat, frozen atmosphere, was something once. Here is what nobody says out loud. This whole scenario, sun gone, 8 minutes, ice, drift. It is not really a thought experiment. It is a rehearsal, because the sun does end. Not now, not tomorrow. In about 5 billion years it swells into a red giant, swallows Mercury, then Venus, and probably Earth too. After that, it collapses into a white dwarf the size of our planet, but dense enough that a teaspoon of it would weigh as much as an elephant. Then, over trillions of years, it cools and fades, and becomes a cold, dark cinder. The cinder phase is forever. The bright phase, the warm phase, the alive phase, is the short part. That guy with the coffee on Tuesday morning, that school bus, that girl in Tokyo. They are all already inside this story, just very, very early in it. I am not sure what I feel about that. It is not sadness. It is something quieter, like sitting in a room with someone you love who is sleeping and suddenly understanding that the room is bigger than you thought. The sun is still here, for now.